Hello, hardworking algebra kids. I am impressed if you're on here because that means you really want to do well on this test and you want to learn all that you can so that you can feel very good about how well you understand the material. So I'm going to try to go as swiftly as possible, not quite as in detail as the other one, but still enough that you could check and see how you did, okay? And kind of see where issues were. So let's get started. Do these ordered pairs satisfy a linear function? Again, first let's see if they even satisfy a function. 0, 1, 2, 3, 4. Yes, they do. They are a function. Are they linear? Let's check that. 0 to 1, to 2, to 3, to 4. That goes up by 1. So that's all good. Let's check the y's. That goes up 1. That goes up 2. Right away, not going to work. Okay, it's not up by the same amount. What's actually happening is it's getting multiplied by 2. So it's actually a geometric sequence, but it's not a linear. So no, not constant change is how you could describe it. Car travels at 60 miles an hour. The function is here. Gives the car. What is the range? Again, as I said before, highlight those things because I don't want you accidentally giving me the wrong one. Range is y. This is my y right there. So we're trying to figure out what that would be if it travels in x hours. So we can kind of look. If we pick a 0, that means obviously they didn't go anywhere. And if I pick 1 hour, then they go 60 miles. And 2 hours is 120. The question is, so I can see it for sure. It's 0, 60, 120. If we go exactly 1 hour, 2 hours, 3 hours, but could it be 1.5 hours? Could they travel 1 hour and 20 minutes? Yes, they could. So it's really going to be anything bigger than 0. Because I could put in here a half and get 30. So our y is going to be a. It's a big range. It's a continuous graph. It is not a discrete graph. So we get that inequality going. All right, so on the next thing here, we are at a convenience store. Bottles of water cost $1.20. And the function is right here, so it's $1.20 times the number of bottles that we have, where f of x is your cost of the bottles that you buy. Graph it. Okay, fair enough. So what happens if you buy 0 bottles? Well, you pay 0 cost. All right, what if you buy 1 bottle? How much do you pay? $1.20. What if you buy 2 bottles? $2.40. Okay, so let's stop for a minute. Well, actually, let's do one more. 3 bottles, $3.60. So what if you, or 1.2, 2.4, 3.6, I'm just putting it in terms of money here. Is this continuous or discrete? It is discrete. I hope you said that because you can't buy a half of a bottle in a grocery store. So we aren't going to have a continuous graph here. We're going to have just a bunch of dots. We're going to have 0, 0, and we're going to have 1, and you can hardly see my lines on this, but that's okay. I'll just kind of guess 2 and 3. It's going to be up there somewhere. And that's all I do. I don't connect them. This is a discrete graph, and when I do the range, it's going to be the same. I'm not going to have an inequality. I'm going to have a list of values. So my domain starts here. I could pick 0 or 1 or 2 or 3, etc. And what numbers are these? These are not, why did I have natural written on my sheet? That is so not right. It is not natural. These are the what numbers? These are the whole numbers. And then the range, again, we're going to list them separately. Starts at 0, 120, 240, 360, etc. with the ellipses. All right, next, find the x-intercept of the equation. If I want the x-intercept, I cover up the y. Ooh, that's even easier. So the x-intercept is what? 20. What if I said I wanted the y-intercept? What would it be? Solve that. Divide both sides by 5. Y would be equal to 4. That would be the y-intercept. The recycling center pays 2 cents per aluminum can and 5 cents per glass bottle. So they put the equation together here for you. So 2 cents for every aluminum can. So X, they probably tell you that right here, the number of cans, X, and 5 cents for every bottle. And Y is your bottles. And they want to know what that would be if you need to earn $1. Okay, so since these are in cents, 2 cents, 5 cents, I'm not going to put 1 here because $1, we're talking dollars here and we're talking cents here. I'm changing that dollar to pennies, 100. What is the value of each intercept and what does it represent? Okay, let's see. If I want the x-intercept, I'm going to cover up the y. So, what is my x-intercept? Divide both sides by 2 and you get what? 50. Okay, now what does that represent? What was the x? 50 what? Cans. And then how many bottles? Well, if you covered up the y, remember, what are you doing? You're making it 0. So you're saying 0 bottles. But it didn't really ask you to do that. It just says what does each represent. So that would just be cans. So let me... Love this. Love it. I should buy stock in it. Okay. Y-intercept. Cover up the x. So now I got 5y, and be careful, there is a positive, but sometimes that could be a negative, so watch that. 5y equals 100, divide both sides by positive 5, and you get 20 bottles. Okay, here's one of those charts. So the table shows the percent interest on a new 30-year homeowner's loan for different months after August 16th, 2004, during which time interval did the percent of interest increase? What was the rate of change? Two things. Okay, so remember, these are different. So this is going by 6, and then this is 3, and then this is 2, and then this is 1. So which one's the easiest? It would be this one, right? The 1 monther. So we can do that in our head. 5.37 minus 5.27, what's the difference? 10 cents interest per what? Or 0.1% interest per month. Well, these other ones, let's look here. So I'm going from here to here, so I'm subtracting, so it's a negative 5.27 minus 5.3. It's a negative 0.03, and we're dividing it by 2 months. So it is a negative 0.015%. Wow, this is eensy weensy printing. I should have taken more room. 5.3, I'm going subtracting the same way, minus 5.14.16 divided by now 3. And that's 0.05% per month. And now let's do that one. That's 5.14 divided by 5.4 or 5.14. It's going to be negative anyway, so it's not really needed to do this, but I still want to show you. Divided by 6 is negative 0.05 per month. Okay, so first of all, it said during which time did it increase the most. So as soon as we see the negatives, those two are just gone. Those are negatives. And then we have the 0.1 and we have the 0.05. So which one's bigger? It's right here, this realm. So which time interval? Time. So 11 to 12 months is how I would write that. And it says, what is the rate of change? And it's right here, 0.1% per month. Or you can write per. That's the same. The symbol means per. All right, let's keep going. I want to take so long with this one. Find the slope of the line. Oh, well, you have to do absolutely nothing here, do you folks? It is a horizontal line. And what is the slope? You are cross-country skiing people. What is it? 0. Horizontal line is always 0. Now, if you wanted to, you can certainly take the numbers 1, 2, and -1, 2. And when you subtract, you're going to find you get 0, as you should. Okay? What's a vertical line? What's a slope? It is undefined. Like that. So when we go into this one, number 8, it says find the slope of a line that contains these points. So we have to again use our slope formula. So subtract your y's and subtract your x's. And we get 9 over -3, which is a -3. So that would be G. And we move on, and we have which are the coordinates of the midpoint of JK with endpoints there. Okay, so they didn't give you the midpoint. They asked you to get the midpoint. So remember, that's averaging. So we're going to average the x's and average the y's. So we have -9 plus a -11. And we have 0 and 5. So we're adding and dividing by 2. So I get a -20 divided by 2. It's a -10. 5 divided by 2 is 2.5 or 5 halves. Let's see. There we go. And what are the coordinates of the midpoint? Okay, so we're trying to find that midpoint. Oh, and it's another one like this? Oh, wow, that's easier, isn't it? So the endpoints are these, so we're going to do the same thing. 3 plus a -5 over 2, and -6 plus 2 over 2. -2 over 2, -4 over 2, that's -1, -2. So that would be B. All right, which represents the distance? Okay, subtract your x's. 5 minus 1. 6 minus 3. 4 squared is 16. 3 squared is 9. Square root of 25 is 5. Boy, can you tell I'm going to have company coming here soon? I'm wrapping through this pretty darn fast. Which equation is not a direct variation? Okay, well remember, direct variation has to always be in the form of y equals k, no, x equals k y over x. K equals y over x. Y equals kx. Yeah, there we go. All right. So let's see. Y equals kx. Yes, that is in direct variation. We have to solve these for y to see if we can get that. Y equals -1/2 x. Yep, that one works. Oh, do you guys remember the little trick we did with this? If you have them in this form, standard form, it's the one that equals what? 0. That's the one that actually works. Because watch, when you solve, you get just the 3x because that's 0. So then you divide by 2. So that's in that form, y equals kx. So our constant is 3/2, our constant is -1/2, our constant is 50. But watch what happens here. Because it's a 10, it stays, and then I get that extra thing in here. So it is not, it's a linear equation, but it's not a direct variation because I end up with this over here. So B was the answer. All right, which equation does the line with slope of this and this and this? All right, so it's mx plus b is the form it's in. Oh, but you will probably have to use point slope because that's what they give you. So y minus, this is my x1 and my y1, y minus 4 equals 5 times x minus a negative 2. So y minus 4 equals, I'm going to distribute here, 5x plus 10. And I'm going to add 4. Y equals 5x plus 14. There it is. So use the point slope form, solve to get it into y slope intercept form. Graph the line with the slope of this and the y-intercept of this. Which one do we graph first? Y-intercept is 4, and the slope is negative 1/2. Remember, you can put the negative with whichever one you want. I'm going to put it with the top. So I'm going to go negative 1, run 2. And I'm going to grab my straight edge. And voila. Boy, we are a moving people here. Okay. Now, which equation describes the line with the slope of that and the point? Same thing. Slope x1, y1. And there's my slope. So y minus the y1 equals slope times x minus the x1. Remember, I'm using slope or the slope point slope form. All right. Do we have that for an answer? Well, sort of. That's a plus, right? So there it is. Okay, and the next one, which equation describes the line with that slope and that point? Okay, so we're just popping those in again into that same equation up there. So it would be y minus the y equals the slope times x minus the x. So the one that is this becomes a plus, so it's b. Which lines are parallel? Okay. Y equals 2 is a what kind of line? It's a horizontal line through 2. What's the slope? 0. What's the slope here? 1. What's the slope here? 2. What's the slope here? 2. So 3 and 4 are our answers there. That one was kind of easy. You didn't have to solve. Sometimes you remember you have to solve to get it as y equals. Which equation describes a line that passes through this and is perpendicular? Remember, when it talks about being parallel or perpendicular to a line, you're just trying to get the slope out of this. So the slope of this is 2, but since it's perpendicular to it, I got to do my reciprocal and opposite sign. So I have a point, and now I just need my slope. So I'm going to flip it and take the opposite sign. So now I've got those two, and it looks like it's in y equals mx plus b form, but we can use point slope form and then solve it. Distribute. And a negative half times 6 is a negative 3. And hopefully we got that answer. We do. It's right here. It's G. So just remember, when you're given a point and a slope, you can pop it into here. Be careful with your different things. I had subtract a negative. I had to make that positive. Then you got to distribute. Just watch your signs. All right, and our last one is to graph these. So they're in, let's see, they're in Was my other one in it? I'm trying to remember if the other one was. Shoot. Because these are already in slope-intercept form, so I don't have to use an XY chart. I feel like I used that on the other one. You don't need to, because you have an intercept of 4, and then a slope of -3/1. So 1, 2, 3, 1. So there's one of them. That's my f of x. That's my original one. That's f of x. And then I have a slope of 4, or an intercept of 4 there too, but it's 3/1. So rise 3, and 1. So that is my g of x. So then it's saying, well, what is it? Well, this one is kind of easy to see. The intercepts are the same, and the slopes are just the opposite. So do you remember which one that is? If you look at it this way, it might help. If you put this as right in the middle, look at, we got the same thing on both sides of that. That's a reflection across the y-axis, let's say. All right, I hope that helped. That was called the speedy version because Mrs. Silva has company coming. All right, take care. Hope you have a good day. Bye.